A trapezoid is a quadrilateral with one pair of opposite sides being parallel. The parallel sides are called the base, and the remaining two sides are called the legs. The angles at the ends of the base are referred to as base angles. A trapezoid with equal leg lengths is called an isosceles trapezoid. If a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. Let's prove this. 1. Draw side AE parallel to side DC. 2. Quadrilateral AECD becomes a parallelogram by the definition of a parallelogram. 3. By the properties of parallelograms, side AE and side DC are congruent. 4. Since triangle ABE is isosceles, the base angles are congruent. 5. Due to the parallelism of side AE and side DC, corresponding angles are congruent. 6. Angles B and C are congruent by the transitive property. 7. Angles C and D are supplementary due to the same side interior angles postulate. 8. Similarly, angle B and angle BAD are supplementary. 9. Since angles B and C are congruent, different angles supplementary to the same angle are congruent by the congruent supplements theorem. Now, let's prove that if a quadrilateral is an isosceles trapezoid, then the diagonals are congruent. Look at the diagram. 1. As an isosceles trapezoid, sides AB and DC are congruent. 2. By the previously established properties, angles BAD and CDA are congruent. 3. Side AD is congruent to itself. 4. Triangles BAD and CDA are congruent. By side angle side congruence. 5. Therefore, sides AC and DB are congruent by CP-CTC. Similar to the mid-segment theorem for triangles, trapezoids also have a mid-segment theorem. If a quadrilateral is a trapezoid, its mid-segment is parallel to the bases and the length of the mid-segment is half the sum of the lengths of the bases. Now let's discuss kites. A kite is a quadrilateral with two pairs of consecutive sides that are congruent. If a quadrilateral is a kite, then its diagonals are perpendicular. Let's prove this. 1. Given that side AB and side AD are congruent and side CB and side CD are congruent. 2. According to the converse of the perpendicular bisector theorem, points A and C lie on the perpendicular bisector. Let's briefly examine the converse of the perpendicular bisector theorem here. In the diagram, if the lengths of segments PA and PB are equal, line PQ bisects segment AB perpendicularly at point Q. 3. Points A and C form line AC. 4. By the definition of perpendicular bisector, side AC and side BD are perpendicular. See you next time.